Section 6.1 is on angles of polygons. First we have the polygon interior angle sum theorem. Now an interior angle of a polygon is an angle that's obviously on the inside. So in this hexagon right here, angles 1, 2, 3, 4, 5, and 6 are all interior angles. The theorem says that the sum of the measures of the interior angles of an n-sided convex polygon is s equals 180 times n minus 2. So no matter how large your polygon is, n is the number of sides. You do n minus 2, multiply that by 180, and that gives you the sum of all of these angles. So the measure of angle 1 plus measure of angle 2 plus measure of angle 3, so on. That's going to add up to 180 times, in this case, 6 minus 2. So let's try a couple examples here. Find the sum of the measures of the interior angles of each convex polygon. Now, a heptagon, for a heptagon, it has 7 sides. Change my pen size here for a minute. Okay, a heptagon has 7 sides, so that means n equals 7. So I'll use my formula, s equals 180 times n minus 2, and plug in 7 for n. So s equals 180 times 5, or the sum of the interior angles of a heptagon is 900 degrees. Now sometimes a polygon can be so big that we don't have a special name for it, so we just name it by the number of sides. So example number 2 here asks for the sum of the measures of the interior angles of an 18gon. So obviously in this case, n equals 18. So we'll plug that into the formula. 180 times 18 minus 2, or 180 times 16, which is equal to 2,880. So the sum of the interior angles of an 18gon is 2,880 degrees. Here's another couple examples. It says find the measure of each interior angle. And in example 1 here we have a quadrilateral, a 4-sided figure, and we have the measures of the angles are x, 2x, 3x, and 4x. Now what we know from this is that n equals 4, and so we need to find the sum of all of the angles. So 180 times 2, or the sum of all 4 of those angles is going to be 360. So I need to say x plus 2x plus 3x plus 4x equals 360, or 10x equals 360, or x equals 36. So that means the measure of angle A, since it's equal to x, is equal to 30 degrees. The measure of angle B, oops, wait, sorry, mistake, not 30, 36. So the measure of angle A is 36. The measure of angle B is 2 times x, which is 72. The measure of angle C is 3 times x, which is 108. And the measure of angle D is 4 times 36, or 144. And you could check this by adding up those numbers, and they should add up to 360, because the sum of the interior angles of a quadrilateral, a 4-sided polygon, is 360. Here we have a hexagon. In this case, n equals 6. So let's start by finding the sum of the interior angles. So the sum is going to be 180 times 6 minus 2, or 180 times 4, or the sum of those 6 interior angles is going to be 720. So let's write our equation. I think I'm going to do it down here because it's going to be kind of long. X plus 2, which is angle A, x minus 8, plus x plus 7, plus x minus 3, plus x plus 6, plus x minus 4, equals 720. So that's going to give me 6x And what do those add up to? Negative 4, 3, 0, plus 2, I believe. Oh, wait a minute. Nope, I think I added that wrong. Did I get them all correct? Negative 6, 1, negative 2, 4, negative 4. Okay, so they all cancel out. Sorry about that. So 6x equals 720. So x is equal to 120. So the measure of angle A is x plus 2, or 122. The measure of angle B is x minus 8, or 112. Measure of angle C is x plus 7, or 127. Measure of angle D is x minus 3, or 117. Measure of angle E is x plus 6, or 126. And the measure of angle F is x minus 4, or 116 degrees. To find x, plug it back in to find the measure of each angle. So this example says find the measure of each interior angle of a regular polygon. Recall that a regular polygon has all angles and all sides congruent. So all of the measures of all of the angles are going to be the same. All of the sides are going to be the same length. So first thing I'd like to do is find the sum of the measures of a regular octagon, the measures of the interior angles of a regular octagon. So n equals 8. So s equals 180 times 8 minus 2, or the sum of those angles is going to be 1080. Now, so that's the sum of the interior angles of a regular octagon. So the measure of one interior angle, since all of the interior angles are the same, so the measure of one interior angle is going to be 1080 divided by 8, since there are 8 angles and they are all the same. So that's going to be 135. So, and next time you see a stop sign, which is a regular octagon, each one of those interior angles measures 135 degrees. Here's a regular 16gon. So let's start by finding the sum of all of its interior angles. So 180 times 16 minus 2, or 180 times 14 is 2,520. So the measure of one interior angle of a 16gon is going to be the sum of all of the angles divided by the number of angles. Since they're all the same measure, we can just divide by that, and that gives me 157.5. So each angle of a regular 16gon, each interior angle is 157.5 degrees. For this example, we have the measure of an interior angle of a regular polygon is given. Find the number of sides of the polygon. So I know that this is one angle, interior angle of the regular polygon. If I were to multiply this by the number of sides, that would give me the sum of the interior angles. Let me say that again. This is one interior angle of a regular polygon. If I were to multiply that by the number of sides, that would equal the sum of the angles. So one angle is 150. I multiply that by the number of sides, which I don't know, because that's what I have to find. And that should be equal to our formula for the sum of the sides of a regular polygon. Okay, so that's going to be 150n equals 180n minus 360. So just go ahead and distribute, because what we're doing here is we are solving for n. Subtract 180n from both sides. Gives me negative 30n equals negative 360, and divide both sides by negative 3. That gives me n equals 12. So in other words, a 12-sided polygon, which is known as a dodecagon, has an interior angle with a measure of 150 degrees. Suppose our regular polygon has an interior angle of 170 degrees. So 170 times the number of sides should give me the sum of all of the interior angles, which I don't know because I don't know what n is, which is what I have to find. So again, distribute, and we will solve for n. So that's going to give me negative 10n equals negative 360. So n is equal to 36. So the measure of one interior angle of a regular 36gon is 170 degrees. Now we have a theorem for the measure of the exterior angles of a polygon. The polygon exterior angle sum theorem says that the sum of the measures of the exterior angles of a convex polygon, that would be one angle at each vertex, is 360. So let's take a look at this picture here. So we have a pentagon, okay, and I extend each side in one direction. It almost kind of looks a little bit like a wheel here, where you extend each side. The angle that is formed by the extension of that side, kind of like an exterior angle of a triangle, is called the exterior angle of a polygon. But we only count one at each vertex. So I could extend this side of BC out here, but that would give me another angle, so I only need one at each vertex. So angles 1, 2, 3, 4, and 5 are exterior angles, and the sum of those angles, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5, is 360 degrees. No matter how large or how small your polygon is, the sum of the exterior angles is always 360 degrees. So let's take a look at a couple examples here. So we need to find the value of x in this diagram. So again, we have a convex pentagon because it has 5 sides, and degree measures for all of the exterior angles. Those will actually add up to, all of those exterior angles will add up to 360. So let's write an equation for that. Equals 360 degrees. And combining like terms, that gives me 4x plus 152 equals 360. Or 4x equals 208, and dividing by 4, x is equal to 52. So again, all of the exterior angles of a polygon always add up to 360 degrees. And our last examples here say find the measure of each exterior angle of each regular polygon. In a dodecagon, that has 12 sides, so n equals 12. So I'm looking for the measure of one exterior angle of a regular polygon. Well, I know since all of the interior angles are the same, all of the exterior angles are going to be the same, and I know there are 12 of them. So I just need to take 360 divided by 12, and that gives me 30. So one exterior angle of a regular dodecagon measures 30 degrees. Example number 2, in a 36gon, n is equal to 36. That's the number of sides, and divide 360 by that because there is going to be one exterior angle at each vertex, and there are 36 vertices. So that tells me that one exterior angle is equal to 10. So a couple formulas you need to memorize. This one's really straightforward, that the sum of the exterior angles of a polygon is 360. And then you do need to memorize this formula here at the very beginning, that the sum of the interior angles is 180 times n minus 2.